The curve G has equation y equals 3 minus 1 over x minus 1 for x not equal to 1. Find an equation of the asymptote to G which is parallel to the x-axis and the y-axis. Find the coordinates of the point where G crosses the x-axis and the y-axis. Sketch G, showing clearly the asymptotes and the coordinates of the points where the curve crosses the coordinate axes. A straight line L intersects G at the points P and Q. The x-coordinate of P and the x-coordinate of Q are roots of this equation. Find an equation of L. Okay, so I've split the question up because it's a long question into these parts here. First of all, the asymptotes parallel to the x and y axes. So as x tends to infinity then, we can see that y, put in large X, this will become increasingly small, so it tends to 3. And x tends to minus infinity. And again, this will be 1 over a large number will be very, very small. Very, very small positive, just above 3, so y tends to 3 again. So y equals 3 then is an asymptote. Now if I was going to shoot up to infinity either side of 1, isn't it? So if we tend to x tends to 1 from above, then y will tend to just slightly bigger than 1, x. This will be small positive, this will be large number, positive, and then a negative, large negative. So y will tend to minus infinity. And x tends to 1 from below. Just coming up to 1, take away 1, this will be small negative, this will be large negative, and then in combining the minus, large positive, so y will tend to infinity. So x equals 1 is also an asymptote. Okay, that's part A then. One parallel to the x-axis, so parallel to the x-axis y equals 3, so this is part 1, and parallel to the y-axis, this is part 2 here, isn't it? Okay, part B. Let's move down the page then. Find the coordinate of the point where G crosses the x-axis and the y-axis. So our curve is 3 minus 1 over x minus 1. So 3 minus 1 over x minus 1 is the curve in question. So here y equals 0 when, well, this will equal 0 when 1 over x minus 1 is equal to 3, isn't it? Just move this through the equals and we get 1 over x minus 1 equals 3. X minus 1 then, move this thing from divide up to times, and at the same time move the 3 down from times to divide. And I've written it from right to left, so x is equal to then, add 1 to a third, you get 4/3 when you move the 1 over. So x is equal to 4/3, y equals 0. So when it crosses the x-axis, so this is part 1. Here. Now where it crosses the y-axis, that's when x equals 0, y is equal to 3 minus 1 over 0 minus 1. 3 plus 1 then, because this is minus 1, minus 1 is plus 1, 3 plus 1 is 4. So y equals 4, and that's part 2. Where G crosses the x and the y axes, respectively. So we've done that. Now C, sketch G showing the asymptotes and where the curve crosses the axes. Okay, so let's do a quick sketch. I'll do it as best I can with a digital pen. So here's the axes. Okay, here's the x-axis. Here's the y. 0. Now there was an asymptote at 3, wasn't there? Y equals 3. There it is. and that's the value 3. There's also an asymptote at 1, so let's put that in. Oops. Okay, now just above 1, we said above in the thing, didn't we? Just above 1, as it tends to 1 plus, y tends to minus infinity, and it tends to 1 minus, y tends to infinity. So above 1 it's minus infinity here, below 1 it tends to minus infinity. As x tends to infinity, let's just look back at that part. As x tends to infinity, y tends to 3. Okay, so it doesn't say which above or below there. So looking at the curve, x tends to infinity, say 100, 1 over 99, just under 3, so it's going to tend to infinity from below. And when x is minus 100, say, this will be minus 101. This will be plus a very small number, so it will tend to 3 from above. So we can see what's happening here. Well, x is minus, yeah, from above. So when x tends to 1 from below, I better check that out, hadn't I? This must be plus. X tends to from below. So this isn't, I've got this run the wrong way here, I must have read it wrong. So when x tends to 1 from below, this will be minus. So this will be plus, so it'll be up here. And x tends to 1 from above. This is now positive, large. So it's negative. So that's what we've got. We've also got when x is 0, y equals 4. So I better extend this line a bit more as best I can. So let's just do that then. Here. So I'm just going to go up a bit as best I can with the digital pen. Y, here's the value 4, say. So it's going to go through there. And also, when x is 4/3, here, it's going to go through 0. And that's 4/3. So the curve, I've got a digital pen, so I'll do dashed lines. It's going to come along here. It's going to go through 4/3, and then it's going to swing down to minus infinity. And the same here. I'm going to just draw it. I'll draw it in a different color. So it's going to come down from infinity, swing through 4/3, and then tend to 3 from above. So I just want to check those limits here and here that I wrote at the beginning before we go on. X tends to 1 from above. X tends to 1 from above. Let's have a look at this. 1 from above, y tends to, 1 from above would be positive, this would be negative. Yeah, so y negative, which is what we've got here, so it was okay. Okay, so that's the sketch, sorry. So find the coordinates of the g crosses the x. Sketch G, showing the asymptotes where the crosses the axes. A straight line L intersects G at P and Q. The x-coordinate of Q are roots of this equation. Find an equation of L. Ooh, so a straight line L intersects the curve at P and Q. So maybe there's going to be an L. Okay. The x-coordinate of Q are the roots of the equation, this. 2x minus 3 equals 1 over x minus 1. Find an equation of L. Okay, well here 2x is equal to 3 minus 1 over x minus 1. Okay. Okay. So what have we got then? Right, so the line, well the line L is y equals mx plus c. And we've got this curve y equals 3 minus 1 over x minus 1. So, for that line to intersect that line, we need mx plus c needs to equal the 3 minus 1 over x minus 1. And we're told that this holds, so we can replace that by 3 minus 2x. So minus this will equal minus this, so it will be 3 minus this, which is plus 3, minus 2x. So that's equal to minus 2x plus 6. So that tells us then that m is equal to minus 2 and c is equal to 6. So y is equal to mx minus 2x plus 6 is the equation of the line L.